Hello. In this video, I will be reviewing the basic ideas of the mathematics topics that you will need for this physics course. As you may know, you are taking an algebra-based, trig-based physics course. There is no calculus involved there, so you're not going to be doing any differentiation or integration or any of that, but you will be doing a lot of algebraic manipulation, and you will be using trigonometric functions to calculate things, to solve problems and so on. So what I want to do in this review is to brush up on the previous math skills that you have acquired from your numerous algebra courses that you have taken in high school and maybe in college, and hopefully this review will help you read the textbook with good understanding, succeed in doing the homework, and succeed in the exam, in taking the exams. So I highly recommend that you should watch this video, all of it. I am going to try my best to keep this video less than 60 minutes. So let's begin. So we'll begin with the basic thing that I'm sure you are familiar with, and that is if you have two quantities, say x to the m multiplied by x to the n, of course, when you multiply those two quantities, if the bases are the same, xx, then it's x to the m plus n, right? Also, we have x to the m divided by x to the n. In this case, we would subtract the powers, the upper one minus the lower one, so it's going to be x to the m minus n. Is that right? Something like, let's say, if I have x squared times x cubed, that will be x to the fifth. But if I have, say, x to the fourth divided by x, for example, so that will be x to the third, because this is basically 4 minus 1, because this is x to the 1, right? It's just invisible, but it's there, right? Okay. Another thing, if I have a double power, say, for example, x to the m to the power of n, you see this a lot. So basically, if you have a double power like that, you multiply the powers, you don't add them, so it becomes something like x to the m times n. An example of that would be, let's say, x squared to the power of cubed, so that will be x to the 6, okay? Another example related to this, suppose I have, let's say, 4 pi cubed r squared. Let's say I have e, all of that divided by, let's say, v cubed, and all of that to the power of, say, squared, okay? This is not unusual equation. You will see equations like that crop up when you are solving some physics problems. You'll see a bunch of stuff in that fashion, and then all of it raised to some power. And what you do in this case, you simply take the, let me go to the third, what is that? There we go. What you do basically is, let me put it so you take this power and you multiply it by the power of every item in there, okay? Here and all of that there. So, of course, this is 4 to the power of 1, pi to the power of 3, r squared, e to the power of 1, and then v cubed. So what you will get in this case, it'll be something, oh, let me change the color. So what you will get in this case is something like this. 4 to the power of 1 times 2 is 2, pi to the power of 6, because 3 times 2, and then times r to the power of 4, because 2 times 2, and then e to the power of 1 times 2 is 2, divided by v to the power of 6. And that's basically how you do it, okay? Simple stuff, I hope. One more identity, and that is if I have, let's say, 1 over x to the power of n. If I wish to lift this x to the n to the numerator, I can do that, and it becomes x to the minus n. So basically what you do, the base would stay the same, x, but it's the power that changes sign. You got that? So the converse is also true. If I have, say, let's say I have x to the power of n here, I can make it 1 over x to the minus n. Or for example, let's say I have a to the power of -3, and I can rewrite it as 1 over a cubed. You see what I'm saying? We always like to end the final answer with positive power rather than negative power. Okay. Here's an example. Let's say I have a over b to the power of, let's say, minus n. So how do I do that? Well, you basically distribute. Remember, this is a to the power of 1. Let me change the color again. So this is a to the power of 1. This is b to the power of 1. So what I'm going to do, just like I did here, so I'm going to multiply this power here. So that's going to be a to the power of -n over b to the power of -n. And then I would use this identity here. So if I want to make this a to the minus n to be positive, I can bring it down, and this will be to b to the minus n. I can bring it up. So basically, I flip the whole thing vertically, so it becomes b to the n over a to the n. You see what I'm saying? I can also take it as one single power, like a to the a divided by b, to b divided by a to the power n, if I want to do that. Okay. So one more. Square roots. Let me just go over square roots. I'm sure you know how to do it, but just again, just a quick review. When I say square root of 9, this square root means 9 to the power of 1/2. Okay. So square root of x means x to the power of 1/2. Cube root of x means x to the power of 1/3. Nth root of x means x to the power of 1 over n. Keep that in mind. So the square root, or the root itself, is to the power of 1 over the number. Okay. This is important. Let's say, for example, I'm using my notes here. Let me flip the pages. So for example, if I ask you what is, let's say, what is a square root, fourth root of 81 without using a calculator, how would you do something like that? Well, I know that 81, so let me put a question mark. So I know that 81 is equal to 9 times 9, and 9 is 3 times 3, so that will be 3 times 3 times 3 times 3, and that makes it 3 to the power of 4, right? And then I can go back to my root here, so it becomes fourth root of 3 to the power of 4. Let me convert this fourth root into a power, so it becomes 3 to the power of 4, all of that to the power of 1/4. And as you can see here, just like you have a double power, just like here, right there, see that? So we can multiply the powers, and in this case it becomes 3, simply, because 1/4 times 4, and that's equal to 1, and there we go. So we have the answer is 3. So the fourth root of 81 is equal to 3. You see what I'm saying? Okay. Another thing, let's say, regarding roots, before I forget, what comes in physics in the following way. If you remember, if you go back to your math class, your teacher would, let's say you've had something like x squared equals 16. And let's say you are supposed to solve it. So how would you solve that? I'm sure you've done that before. So what you do is you take the square root of both sides. You'll end up with x equals square root of 16. So x equals plus or minus 4, remember? And that would be your final answer in an algebra class. However, in physics, this is not a legitimate answer, because here you have two answers. Especially if x here, for example, is represent time. So suppose that in physics, let's say you end up with the following equation. T squared equals 16, where T here is time. So what that means, well, if I'm going to take the square root of this equation, so it becomes T equals plus or minus 4 for a second, let's say, for example, right? Well, are we talking that there is a time called -4? That doesn't make sense, right? There is no such thing as negative time. So therefore, we cannot really take the square root and use those two numbers, -4 and +4. You have to pick one that makes sense. So for example, time is always positive. So therefore, square root of 16 in this case would basically equals to 4 seconds, not -4 seconds. You see what I'm saying? So you want to be careful about it. In physics here, unlike mathematics, you basically take both solutions, because both solutions could be legitimate in mathematics. But in physics, you have to know what is the nature of that variable x. If it represents time, well, we have to only pick the positive root, okay? At the same token, if I have, let's say, v squared, let's say I have, let's say velocity, which means speed, right? Speed with direction. So let's say I have an object that is moving downward like that. So here is the velocity of the object going down. And as you know from basic geometry, if I have a Cartesian system here, this is the positive x, this is positive y, negative x, and this is negative y. So anything moving down is a negative, moving up is positive, moving to the right is positive, and moving to the left is negative. So when I have a velocity going down, so that means, I mean the object with velocity moving in the negative direction or moving down, that means, let's say I'm calculating something and I end up with v squared equals some number, let's say 16, okay, for example. So now I'm going to take the square root of both sides, and that's going to give me a plus or minus 4, let's say miles per hour, okay, so miles per hour. Well, which answer is the correct one? Positive 4 or -4? You need to look at the nature of the problem that you're dealing with. We are dealing with an object that is falling down. That means we have to take the negative sign, so therefore the correct answer would be -4 miles per hour, not +4 miles per hour. You see what I'm saying? So you don't take both. You take one, but you take one that makes sense. So for this problem, for example, we are making just a, just a hypothetical situation where an object, say, is falling down and so on. However, if the object is moving up, for example, and we end up with the same equation, because it's moving up, so we're going to pick the positive answer. You got it? Okay. All right, good. So let me just review this Cartesian system here. As far as physics is concerned, it looks something like this. It's x and y, but you can also think of it like this is to the right, which is positive. This is up, which is positive. This is to the left, which is negative. And this is going down, which is also negative. Okay? Okay, good. The next topic that I want to talk about, there are several short topics that I'm going to cover, and that is scientific notation. I am not going to elaborate on scientific notation because you can, there are tons and tons of videos on the YouTube where you can look them up. There's a lot of details on them. I don't want to spend too much time on them. Just for the sake of completeness, I'm going to cover it at a very brief level. So scientific notation. So the reason we use scientific notation, because in science in general, not just physics, in chemistry, biology, astronomy, especially astronomy, we deal with extremely large numbers or extremely small numbers. You see what I'm saying? So, for example, the mass of the electron, for example, let's say the mass of the sun. The mass of the sun is roughly 1 with 31 zeros. Okay? So it's extremely large. We're not going to be writing 31 zeros every time we're doing some calculation for the mass of the sun. The mass of the electron is 9.11 times 10 to the negative 31 kilogram. What that means, it means it is 1 over, and then we have 1, 0, 0, 31 zeros. So it will be impractical to keep writing this very, very large number of digits just to do the calculation. So scientific notation is a way to write the number in a shorthand way. So that's why we use it, and that's why it is important. When we write scientific notation, we are basically it's a quantity that is expressed in decimal number, and the best way to express it is that you have a number, one-digit number, decimal, and then number, or maybe more numbers, times 10 to the power of some number. This is how scientific notation looks like in general. In your mind, it is basically one decimal, the decimal point is here, and you usually have one number here, just one digit. I mean, it doesn't have to be, but that's basically how it is written in general, conventionally, okay? So you have a decimal point right here, then you have one digit here, just like, say, the mass of the electron, and then you have maybe a couple of digits or more. It depends on how accurate you want it to be. So there is a number of digits here, but to the left of the decimal, usually it's just one digit, okay? Then times 10 to the power of this number. This number usually plus or minus. If it's minus, most likely it's a tiny number, just like the mass of the electron. If it's positive, it will be like the mass of the sun times 10 to the power of positive 30, for example. You know what I mean? I think the mass of the sun is something in the range of 2 times 10 to the 30 kilogram. Don't quote me on it, but it's around there. So this is positive 30. So this is like 2, and then you have 30 zeros beside it. See what I'm saying? Okay, so let me give you an example and show you how that works. So let's say, for example, I have 1 million. Let's say I have $1 million. 1 million, okay? So how would be a shorthand notation for it? Well, the way you do it, let me just get rid of this the comma here. So basically, if I have 1 million like that, of course the decimal point is right here, and as I told you here, you want the decimal to be to the left of the first digit, to the left. You see what I'm saying? To the left of the first digit. So basically what I want to do, I want to move this over there. You see what I'm saying? Now you want to count how many steps I'm going to go. Let me put it in a different color. So here's 1, 2, 3, 4, 5, 6. So I have moved 6 steps to the left, so it becomes 1.0 or 0, 2 zeros if you want, times 10 to the 6, and there we go. You see what I'm saying? Here's another one. Let's say I have 63000, and the decimal is here. Again, maybe the decimal is invisible. And let's say, how would you write it? Well, obviously the decimal should be here. You see what I'm saying? But it's just not written. So now you wanna count how many steps you have to go until you get to the left of 6. To the right of 6. So it's going to be 1, 2, 3, 4. So it becomes 6.3 times 10 to the 4. You see what I'm saying? Okay, here's another one. Let's say I have this one. Let me just go back to black. Let's say I have 0.00656. Okay? How would I write it in scientific notation? Where should the decimal point be? Well, it should be, you go to the very first digit, which is right here, and we're going to put it right there, in between 6 and 5, right there. You see what I'm saying? So how many steps do I need to go? Let's count them. Just use another color. So it's going to be 1, 2, 3. So 3 steps. But I move to the right. Okay? So that means, start from here. You have 6.56 times 10 to the negative, how many steps did I say? 1, 2, 3. Negative 3. And there we go. Okay? Now, if you have a scientific calculator, which you are expected to get a scientific calculator, especially if you have a Casio, look for a button on the Casio calculator. I'm talking scientific Casio calculator that says ENG. That ENG button, sometimes it is under a shift button, sometimes it's a direct button. It depends on the brand, the model of the calculator that you're using. But this button, basically, when you have a number, let's say you're doing some calculation, you end up with some credit card number, and you want to convert it to scientific notation, you just push that button, ENG, for engineering, that's what it stands for, and it will write the number in scientific notation very quickly, in one, just the push of a button. If you cannot find it in your calculator, you're welcome to send me a picture of your calculator. Just take a picture of it, if it's Casio, and maybe I could find it for you. But it's basically there. Most scientific calculators has a button like that, so you may want to you know, get familiar with it. It will save you a lot of time. Okay, next. Okay, now I want to talk about solving equations, specifically the quadratic equation. The quadratic equation. Again, I'm sure you're familiar with it. I just want to go over it very briefly, just to remind you, especially if you haven't seen math in over a year or so. So the quadratic equation basically looks like ax squared plus bx plus c equals 0. This is an extremely important equation in physics. Of course, as you may know, if you may remember, when you graph it, you end up with a parabola, right? For example, the basic one, if y equals x squared, it looks something like this. Here's x and y. Whoops. Here's x and y. It's always difficult for me to make a vertical line in this stylus pen. And that is the x squared like that. You see what I'm saying? It's symmetric, it looks the same. So anyway, that's how it looks like. So when you have an equation like that, it looks a little bit more complicated, but it's still parabolic, okay? Where a, b, and c are the coefficients of the quadratic equation. Now, if I want to find the root, which is basically the most important thing that you need to know about the quadratic equation, is how to find the roots of the equation. You always get two roots. This is the fundamental theorem of algebra. Basically says the degree of the polynomial is equal to the number of roots. Of course, we have the second degree equation, as you can see here. So we are expected to get two roots. And to get that root, basically x equals, you know, you want to use the quadratic formula. And I hope you memorize it. So minus b plus or minus square root of b squared minus 4ac divided by 2a. From my experience, most students memorize it because you use it so much. So there it is. This is how you do that. Let me give you a quick example, show you how that works. So let's say I have an example. So let's say I have 2x squared minus 2x equals 24, and then find the zeros. Find the zeros. The word zeros means find the roots. That's another word for it, okay? Or find the x-intercepts. All these words, zeros, roots, or x-intercepts, basically have the same meaning. So the first thing you need to do is you want to put your quadratic equation into the standard form. This is the standard form. So always make it equal to 0, okay? And then try to reduce it as much as possible. So that's what I want to do. And you put it in the same order. Go back to that. So the order is x squared, and then an x, and then a number. You see what I'm saying? So it is ax squared plus bx plus c. Okay, so this is what I want to do. So I have here 2x squared minus 2x minus 24 equals 0, right? Now look for a possibility of reducing it. As you can see, all the coefficients here, the 2 and the 24 are all divisible by 2. So this equation becomes x squared minus x minus 12, and that's equal to 0. And there we go. This is basically my my quadratic equation. So now I'm ready to use the quadratic formula. So let me get the value of a, b, and c. So a here, as you can see, is 1. B is -1. C is -12. And then I'm going to use my quadratic formula. Let me write it down. Minus b plus or minus square root of b squared minus 4ac divided by 2a. And then we plug it in. So I have here x equals 2. Minus b, there'll be plus 1, plus or minus square root of b squared is 1, minus 4 times a is 1, times c is -12, just like that, divided by 2 times a is 1. You see what I'm saying? And then we have plus, let's just go with 1. So I have 1 plus or minus, and then we have 1 plus 4 times 12. Remember, there is a minus and a minus. It becomes a plus. That's why there is a plus here. And then 4 times 12 is 48 over 2. And reducing it further, 1 plus or minus square root of 49 over 2. One more. So 1 plus or minus 7 over 2. As you can see here, we have 2 answers, and we have to pick one of them. Remember, as I told you, most of the time, not all the time, but most of the time, one of them is correct. A lot of times as well, I mean, sometimes also both are correct, but if one of them is a negative and you are solving for time, you just ignore that negative time. You see what I'm saying? Okay, so here I have 2 roots, 1 plus 7 over 2 and 1 minus 7 over 2. So that will be 8 over 2, which is 4. And then this one, -3. And there we go. So we have, like I said, if it is time, so that we can just say that if x represent time, then t equals -3 seconds, for example, is unphysical, and we can be discarded. Discarded. Did I spell it right? Discarded. There we go. Okay. So basically the answer for that, so the answer would be the legitimate answer for this problem, if we did everything correctly, would be something like 4 seconds, for example, not the -3. You just simply ignore it because time is that. However, if you're solving and let's say this x represents velocity, well, my gosh, it's fine. What does that mean? The meaning of it is basically, this means velocity is 4, say miles per hour. The positive means the object is moving to the right. And also, at some, maybe also it's moving to the left 3 miles an hour. Again, it depends on the problem and how those 2 routes are interpreted. You see what I'm saying? It all depends. The whole idea is that be aware of those routes and look for a possibility of eliminating one of them because they could be unphysical. Okay, you see what I'm saying? That's all. Okay, that's basically what I wanted to say about the quadratic formula, the quadratic equation. Let me move on to the simultaneous equations. If I can spell it. What that means, if you have 2 linear equations and that have 2 variables x and y, and you need to solve for the values of x and y, or sometimes we call them a 2-by-2 equation, or 2-by-2 system. That's probably a better term for it. There is 3-by-3, but you will rarely see it in the physics course that you are taking. So I am going to ignore the 3 by 3 system. So anyway, what does that mean? It means I have the following. So I have, what that means is that I have two unknowns. Let's say I have the following equation: x plus 4y equals 14, and let's say 3x minus 5y equals -9. There we go. I have two equations, and I have two unknowns, right? Two equations, equation 1 and 2. And I have two unknowns, x and y. So always you will be able to solve for x and y to get the value of x and y if you have the same number of equations. In other words, the number of equations have to be equal to the number of unknowns. Otherwise, you cannot do it. You see what I'm saying? So the number of unknowns have to be equal to the number of equations. Now, if the number of unknowns exceed the number of equations, you cannot solve the system. You cannot solve it. So make sure that you have the same number. So here I have two equations, two unknowns, which again, like I said, they crop up a lot while you're doing calculation in the course, and you need to know how to solve the system. Now, there are several ways of doing it, and I'm sure you've seen that before. There is the method of substitution and the method of elimination. Again, please look them up and learn how to do that. I am basically giving you those keywords just so you can look them up on YouTube or Google, whatever, or if you happen to have an algebra book in your home, you can look them up. So I'm going to go over that very, very quickly. I'm going to solve the same system using the method of substitution, and then later on the method of elimination. So let's start with the substitution. So what the method of substitution, basically, you pick one of those equations, 1 and 2, okay, one of them, and then you solve for one of the variables, okay? So I'm going to pick one, so pick one, and solve for x, for example. So x in this case becomes 14 minus 4y. You see that? Once I solve for one of them, now I plug this thing into 2. And look what will happen, okay? I mean, you will see why I'm doing this technique, this trick, okay? So first thing, you pick one of the equations, you solve for one of the variables. I picked 1 because it's easier to deal with. I solve for x. Now I take this and plug it back into 2, okay? So here's 2. Let me write down 2 again. 3x minus 5y equals -9. So the x is equal to that. So I'm going to put it right, let me put a different color. You like pink? We'll do pink. So we have here 3, and then x now is this. So it's 14 minus 4y minus 5y equals -9. Notice what happens here. Do you see? Do you see what I'm seeing? The x have disappeared. Now I have one equation and one unknown, which is the easiest kind of equations. I can simply solve for that unknown, the y, and I can now go back, once I solve for it, go back and put it right in there in this original equation to solve for the value of x. Do you see the trick? So let's do it. So I have here 3 times 14, that'll be what is that, 42? 3 times 14, I think it's 42. I don't trust myself. Let me use my calculator. Sorry about that. Should be 14 times 3. 42, yes. So we have 42, and then we have minus 12y minus 5y equals -9. And so I have here 42 minus 17y equals -9. And then remember, I am solving for y, so I can move this 42 to the other side, so the -17y equals -9 minus 42. So minus 17y equals to, what is that, 42, 51? Minus 51. And so therefore y is equal to 51 over 17. And should I say 3? I think it's almost equal to 3. So y equals to, let me use it. Yes, it is 3. And there we go. Y is equal to 3. Okay. Now I go back to this equation right here. And let me write it down again here. Sorry, I'll go back to the black color. So I have here x equals 14 minus 4y. And y, we just found it to be equals to 3 right there. So I go back, so therefore x equals 14 minus 4 times 3, and that's 14 minus 12, so therefore x equals 2. And there we go. I have solved the system, and the proper way of writing it is basically x comma y, which is 2 comma 3, and there we go. There's the solution of the system. Now you can check if you've done it correctly by simply plugging those 2 and 3 into equation 1 or 2 and see if you get 14 or -9. That'd be one way to check. But anyway, this is how you do the method of substitution. Now let me show you the method of elimination. Okay. So what you do, let me go back and write down the same system, the 2 by 2 system. X plus 4y equals 14, and then I have 3x minus 5y equals -9. And so method of elimination, basically, you want to add up 1 and 2, and in such a way that one of the variables will eliminate, will disappear, okay? Obviously, if you add them up, x plus 3x will give you 4x, and 4y plus minus 5 will give you -y. You're not going to eliminate, okay? But here is how you do the trick. For example, you pick equation 1, and you multiply equation 1 with -3, okay? This is equation 1. So equation 1 becomes -3x minus 12y equals to -42. You see what I'm saying? And then equation, this is of course the equation 1, the new one. Now equation 2, I'm going to write it down here again. So 3x minus 5y equals -9. Now those two equations are equivalent to the previous equation, the original equation. They're equivalent. Okay? So now what I want to do, I add them up together now. So add them up together. And when you add them, those two will cancel out, right? Minus 3x plus 3x will give you 0. So that's going to be -12y plus minus 5y equals -42 plus -9. You see what I'm saying? It's a little messy, but this is how it's done. So here I have -17y equals to -51. As you can see, this is identical to the equation that we have gotten right there. What is it? Right here, right? So we basically come up with the same answer. So therefore, whoops, ay is equal to 3. And then I can take this and plug it into equation 1 or equation 2 or this one, whatever, it doesn't matter which one. And then with that, you'll end up getting x equals to 2. So our system becomes, the solution is 2 comma 3. And there we go. This is how you this is how you solve it. Okay? Great. Okay. So that's basically how you do simultaneous equations. I want to move on now to a little bit of geometry, equation of the line. Of the line. Okay. As you know, if I have the Cartesian system, x and y system, here it is. And let's say I have a line like this. Okay. This is the line. The general equation of the line, the one that you are familiar with, y equals mx plus b. I'm sure you are familiar with it. You've seen it a million times. This m here in physics, the m we call it mass. In mathematics, we call it the slope. And the slope is basically rise over run. More on that in a minute. Whoops. M. Okay. That's the slope. And then we have here the b, which is basically the y-intercept, which is right here. So this is y right here. This is x right there. This b right here is the y-intercept, which is basically where the line crosses the y-axis. Not the x-intercept, It's the y-intercept, okay? So one way, let me just quickly brush up on this. So we know that the slope is basically y2 minus y1 over x2 minus x1. What that means is that if I have a line like that and you are given, say, 2 points here, you can x1, y1, and this is x2, y2. Remember, there's an infinite number of points on a line, and I'm just going to pick 2 of them. There they are. Any 2 points at all, you can use them to get the slope of the entire line. You see what I'm saying? And by using this ratio. I'll come back to this ratio in a minute. So anyway, let me go back to the equation that I'm dealing with. So you have y equals mx plus b. We call this equation the slope y-intercept form. The slope dash y-intercept form. Okay? It's useful, but there is another form that is also useful, and that's called the point slope form. I'm going to talk about them in a minute, both of them. The point slope form. And when I say point here, I mean any point on the line. There is an infinite number of points. You pick the point you want. It doesn't really matter which one. Any point will do the job. Okay? So what does that mean? Okay, let's say, for example, I think it's better if I explain it through an example. So let's say, for example, I mean, this is how you would see it while you're solving some physics problem or whatever. So let's say, for example, I tell you that I have the following line. Here is the x and y axis. Here is some line. And I tell you that the slope of this line is, let's say, 3. I'm guessing a number, okay? So let's say the slope is 3, and I also tell you that this point right here is given to you, and that point is equal to, let's say it is 1 and let's say 3. Should be more than that. Let's make it 5, okay? So basically this point is 1, 5. Now I ask you, what is the equation of the line? Find the equation of the line. So you always ask the question, what's given to me? Well, what's given to you is a slope and a point, an arbitrary point. I picked any point, okay? What that means, it means I have to use the, oh, I forgot to write down the point slope form. So what is the point slope form? It looks something like this. Y minus y1 equals m times x minus x1. This is called the point slope form. Okay? Where m here, of course, is the slope. x1, y1, again, is any point on the line. Well, we happen to have one. You see what I'm saying? So all I need to do is to take this point. Let me put a different color. What I need to do is to take this point, this arbitrary point, plug it in there, and the slope, and plug it in this equation, and I will end up with some manipulation. I'll end up with the point, the equation of the line, this one. Okay, mx plus b. Let's see how we do it. So all you need to do is you plug in this stuff in there. I never tried blue. I'm not sure how strong it is. Oh, it's not bad. Let's do blue. So I have here y minus y1. Well, what is y1 here, guys? So this is 1, 5. So that means x1 comma y1 is equal to 1 comma 5. So the y1 here is 5 equals to m, which is 3x minus 1. There we go. All I need to do now is to clean it up and put it in the form y equals mx plus b. Okay? Here's how we do it. So we have y minus 5 equals to, multiply the 3 inside, so it's going to be 3x minus 3, y equal to 3x minus 3 plus 5, so y equals 3x plus 2. There we go. Here is my equation of the line. What is the slope here? As you can see, remember, it's y equals mx plus b right here. So the slope is 3. We already know that. And what is the y-intercept there? Well, the y-intercept is 2. What that means, if I go back to the graph here, it's this point right there is actually 2. It's not drawn to scale. I know that this is 5 and it doesn't make sense, but you got the idea. That's basically the y-intercept, and that's equal to b. See what I'm saying? Like that. Okay? Okay, good. Here's another example very quickly. So let's say I have given 2 points. So I have here x1, y1 equals to 1, 2, and x2, y2 is equal to 3, 8. Okay? So I'm given 2 points on some line. Okay, I don't know what that line is. It's some line, okay? I mean, we can draw the line. Let's draw it very quickly, just for the sake of argument. Here it is. I mean, all you need is 2 points to make a line, any line. It's really hard for me to draw a vertical line or the pixel. The vertical, I don't have, the horizontal, I don't have a problem with it, but it's just a pixel, the vertical line. Anyway, so we have 1, 2, so that's a 1 and a 2 right there. Here's the point right there. And then I have 3, 8, so that's a, what is that, a 1, 2, 3 right here. And then the 8 somewhere down up there, let's say it's here. And there we go. And I wish there was a ruler to draw that. It's going to be hard for me to draw the line. But let me use a different color. Orange. So it's going to look something like this. I'll try my best to draw it. I can draw it on a board really easily. But there we go. Okay, so that's basically our line. Sorry, it's a little crooked, but that's basically how it looks like, right? Now, we are asked to find the equation of the line. All right, basically y equals mx plus b. That's what we are asked to find. So the first thing we want to find the slope and then the y-intercept, okay? So the way we want to do it is basically start with the slope, which is the equation of the slope. Let me go back to black color. So we know that the slope equation is y2 minus y1 over x2 minus x1. Recall x1, here's the point, 1, 2, and 3, 8. So that means the slope will be 8 minus 2 divided by 3 minus 1. So it's going to be 8 minus 2 divided by, what is this, 3 minus 1. And that will give us 5 over 2. So there we go. Here's the slope, 5 over 2. And by the way, in physics, when you're doing calculation like that, you will rarely get pretty numbers. You always get fractions and decimals and so on. So you're rarely going to get really nice, pretty numbers like in your algebra class. So it's going to look something like that. So anyway, so we have, there we go. So the slope is equal to 5/2, right? Now, how do I find the equation of the line? Like I said, the best equation to use is the point slope formula, this one. Y minus y1 equals mx minus x1. And again, x1 and y1 is any point on the line. And guess what? We have 2 of them. Which one should I pick? It doesn't matter. You pick whichever you want. You can pick 3, 8 or 1, 2. It doesn't matter. So you pick which one. I'm going to pick 1, 2 just because it looks easier. So in this case, we will have y minus, we're going to pick x1, y1 to be, what is it? 1, 2? 1, 2. And in this case, it's going to be 2 equals to 5/2 times x minus 1, right? All I need to do is to clean it up a little bit. So I have y minus 2 equals 5/2 x minus 5/2. Now I take this 2 right here and move it to the other side, so it becomes y equals 5/2 x minus 5/2 plus 2 over 1. And this is just adding fractions. I am not going to teach you how to do fraction. I assume you know how to do that already. So it's going to be, what is it? The common denominator will be 2 minus 5 plus 4. And that will be equal to, I have my way of solving it. You do it your way. So it's going to be 5/2 x. And that would be equal to, what is that? Minus 1/2. Did I do it right? I feel there is something wrong with this. Hold on, I'm sorry, let me check. 5/2 negative, and that negative, what am I doing here? -5. And that's a plus right there. And so that will be 2 -5 plus 4, and that's -1/2. I think it's correct. Okay, the next topic I want to talk about is basic trigonometric functions, sine and cosine. This is an extremely important topic for your course. Trigonometry. And when we think of trigonometry, we think of triangles. So we think specifically of a right triangle. Trigonometry is a very big subject, but you need to master basically the right triangle. If I can draw it. There we go. So what you have here is a right triangle. When we say right, that means one of the angles is 90 degrees, like this one here. And then we pick one of the angles, either this angle right here or this angle. Let's say this one here, we're going to call it theta. Now the side in front of theta, we're going to call it opposite, okay? And the side that is adjacent to theta, which is here, remember this is the hypotenuse, which is the longest leg in a right triangle. You can spot it very quickly. It's basically the leg in front of the 90 degree. Instead of saying this is the 90 degree angle, right? So the leg in front of it is the hypotenuse, and it is the longest leg. Then you have the other two legs. The one that is touching the angle itself, see this arc right here, which is symbolizing the angle, is touching the arc. This leg right here is what we call the adjacent. Okay, this is how you recognize them. And the leg in front of the angle is the opposite. You got it? So this is how you see them. It's very important that you know how to recognize them. Another way of writing them, in physics, we don't say opposite and adjacent and hypotenuse. We basically say x, y, and the resultant vector. Okay, so let's say this is the angle theta. Since this leg right here, let me use a different color. Since this leg right here is vertical, so we call it y. This leg is horizontal, we're going to call it x, okay? And we can call this r for like resultant vector or whatever you want. We can call it h if you want, like for hypotenuse and so on. But that's basically how we, how we define them, x and y components, we call them. Okay, so the opposite and the adjacent, we give them a name of x and y components. And the reason we use the term component is because of something called vectors, which you will study later in the course. So that's the meaning of it. Okay. So what does that mean? Well, what that means is the following. And I'm going to explain it in a slightly different way from how your math teacher had taught you. Okay, let me go back to how your math teacher had taught you. So basically what your math teacher said, sine the angle theta is the opposite over the hypotenuse, or for our notation here is y over r. See what I'm saying? And the cosine theta is the adjacent over the hypotenuse, which is basically x over r. And then we have the tangent theta, and that's equal to the opposite over the adjacent. So that would be y over x. So those are basically how they look like, right? Okay. The way we think of them is the following. It is in the following way. I would like to write y in terms of the hypotenuse r, or I would like to write x in terms of the hypotenuse r. This is how we write it. In other words, if you look at this ratio right here for the sine right here, okay? So look at, if I would solve for y, let me change the color, sorry. Let's say I want to solve for y. So I have here sine theta equals y over r. So y in this case is r sine theta. This is how we write it in physics. That's what we call the y component. Remember we talked about the components right here? Those components right there? This is called the y component. Okay, so the y component is always r sine theta, provided that theta is measured with respect to the x-axis right here, on this axis. Not this one, it's this one. It's on the x-axis. See, it's touching the x-axis. Now, let's look at x. So the x component in this case will be r cosine theta. That's the x component. Okay? This is how we write it in physics, and this is how you should know how to write it. Okay? I mean, you can start with a ratio, opposite over hypotenuse, and then you can convert it. That's fine. But hopefully, eventually, you will be able to directly get the x and y component just by looking at the triangle. Let me give an example. Suppose I want to make sure the page is within the screen so you can see it. There we go. Is that good? Okay. Let's say, for example, I have the following triangle. Whoop. Try to make it vertical as much as I can. There it is. And let's suppose this is the right triangle. And let's say this angle right here, let's say this one, let's start with the easy one. Let's say this is 30 degrees, okay? And this is the hypotenuse, I'm going to call it r. Let's say this is 8 and this is x. And we are asked to find, r and x, for example, okay? So the question is find r and x. Okay? How do we do it? Well, again, we're going to go back to those two formulas right here. Okay? So as you can see here, this 8 right there is basically y, because this is the vertical. Remember, y is the vertical leg. Okay, always the vertical leg, y. X is the horizontal leg, which matches our notation here, and here is our r. So what's known to us? Well, what's known is y equals to 8 and theta is equal to 30 degrees. Okay? Let me fix it. Okay? So what I'm doing here, I'm looking for a relationship. Well, I know that if we look at the y component here, y is equal to r sine theta, and he's asking us to find r. So therefore, r is y over sine theta. And so we can just plug it in. So we have 8 divided by sine 30. And you can use your calculator for sine 30 or memorize it. I've always memorized it. It's a half. So it becomes 8 divided by half. Make sure that your calculator is set to degrees, not radians. This is very, very important. Otherwise, you'll mess up all your calculation. So 8 divided by half is 16. So there we go. So r is equal to 16. That's how we find it. Now, to find x, well, we go back to the formula, which is right there. X is equal to r cosine theta. I already know what theta is. It's 30 degrees. So x is equal to r cosine theta, and that will be equal to 16 times cosine 30 degrees, cosine 30. Now, your math teacher would have told you, here, let me write it down here. Your math teacher would have said, oh, cosine 30 is square root of 3 over 2, which is true. But we don't write it this way. This is called the exact form. The exact form is not terribly interesting for physics. We basically look for that decimal form, which basically, if you look up, if you actually calculate square root of 3 over 2, it's 0.866, and that's the one we use. So in this case, 16 times 0.866, and therefore x is equal to 13.86. Not degrees, sorry. There we go. Whatever that unit is. And there we go. So we have the value of x and y. You got it? Okay. Let me do one more example, show you how that works, especially in terms of vectors. I'm trying to find another example. I don't have it in my notes. I'm going to make it up. Hopefully I won't make any stupid mistakes. All right. Let's say, for example, I have x and y axis like this. And let's say I have this vector. Okay, if you don't know what a vector is, it's okay. Just think of it like a line, okay? And we got to call that vector A, and it is equal to, pick a number, let's say 5, okay? Whatever that 5 represent. Could be velocity, it could be, you know, force, whatever it is, just 5. We'll just put a unit, you know, whatever unit we're going to put. And let's say that the angle here, let's say it is, say 35 degrees. I'm guessing something, okay? So every vector has what is called x and y components. What that means, so what I'm interested in is in finding this length here, which is called the y component. And here is the x component right here. So the question is, how do I find them? Well, again, simple. So we just say, remember we said, go back to how we calculated that. The y component is right there. It is r sine theta, x equal to r cosine theta. That's all I need to do. So I just say, okay, so the y component of the vector is r sine theta. For our notation here, it looks like y equals a sine theta because we're calling this r, this vector, basically r. Okay, so we're calling it a here. Whichever notation you want, you feel comfortable, it doesn't matter. So we have y equals to 5 times sine 35. I don't know what sine 35 is. I'm going to look up my calculator. Again, please look it up with me. Make sure that you're getting the same answer as mine, which means your calculator is set in degrees. If you get a different answer, that means your calculator is set in radian. You want to switch, okay? So anyway, so sine 35, make sure you got the answer 0.574. So I have here 5 times 0.574. Okay, there we go. And then I multiply this by 5, and that will be equal to 2.87. And that's the value of y, okay? The value of x in this case would be equal to 5 cosine 35, right? Just right there. What is that formula? Right there. So x equals to r cosine theta. For us here, it is, so x equal, I'm going to write it down. So here we have r cosine theta. So that will be a cosine 35 degrees. And that will be 5 times cosine 35 degrees. And cosine 35, let me get that. 35, answer 0.82. So I have here 5 times 0.82. multiply this by 5, and the answer would be 4.1. So there we go. X equals 4.1. There we go. Now, how do I know that I've done it correctly? Well, go back to the triangle. Remember, this is a triangle here, right? Here is a triangle that we have. Looks something like that. Whoops. It's difficult for me. I'm still haven't developed a skill for using the stylus pen that I have. There we go. That's good enough. Okay, so here is the angle. Of course, y here is equal to 2.87. It's 2.87. It's right there. And then we have x is equal to 4.1. So, and r is equal to, excuse me, r or a is equal to 5. How do I know that I've done it correctly? Well, we can use the Pythagorean. What that means is that r is equal to the square root of x squared plus y squared. And let's try it. So basically what I'm saying is 4.1 squared plus 2.87 squared. If I do this and I get an answer of 5, then I've done it correctly. You see what I'm saying? So let's do that very quickly, just for the sake of, make everything complete here. So we have here 4.1 squared, and that gives me 16.81 plus 2.87 squared. That's 8.34. I'm sorry, 8.234. 8.24. That's what I wanted to say. And then we add them up together and take the square root and see if we get to 5. Take the square root. Okay, I got square root of 25.0469, and that's really close to 5, as you can see. We're not getting exactly 5 because of the rounding. That'd be 5.0047. So as you can see, this is close enough. So we have done it correctly. That's the meaning of it. Okay, good. The last topic, I promise you I'm not gonna exceed 60 minutes. I'm already there. The last topic that I want to cover, and that is the natural logarithm. Let me go over it very quickly, and that should do it. Hopefully that should prepare you for the courses, for the physics course that you're taking with me. Okay, logarithms. Should be a fun topic. It's one of my favorite topics in math. I remember when I first learned it, I kind of enjoyed it. Logarithms. Logarithms, I think that's how you spell it. Natural logarithm, I wanted to say. Natural logarithm is basically ln, right? Which basically log to the base e. And logarithms, without the word natural, is log to the base 10, okay? Both are fine, but the one that we use more often is the natural log, okay? So I'm going to be concentrating on the natural log. And if you remember, let's just go over natural log properties. There are 3 major properties. If I have natural log of u plus natural log of v equals to natural log of u times v, if you remember that. And then natural log of u minus natural log of v, there'll be natural log of u over v. And then we have a natural log of u to the power of n, that this power becomes a coefficient down there, so it's going to be n times natural log of u. You see what I'm saying? Those are the 3 characteristics that you want to be familiar with. I'm sure you've done this through your algebra classes. One more thing about natural log, and that is natural log of e is equal to 1. If you don't remember that, that's fine. Just use your calculator. Remember, e is a number, 2.7, what is it, 2.71828. So anyway, so natural log of e is equal to 1. Natural log of 1 is equal to 0. And natural log of 0 is undefined. Okay, undefined. Keep that in mind, okay? So these are kind of useful if you don't have a calculator. They come in really handy. So natural log of e is 1. This is very important. And natural log of 1 is 0. Okay, you can verify, like I said, with your calculator. Okay, why natural log is important? Okay, here's why. It's important because if you have a variable that is in a power in an exponent, it's written as an exponent. Let me elaborate. Let's say I have x squared equals 16. Now that's easy to solve. You just say, well, x equals square root of 16, so x equals plus or minus 4, right? That's basically how you solve it. The reason that you're able to solve it easily is because the variable that you're dealing with here is a base. See that? This is a base. Right? It's a base. And the power is a number. So here the power, and it's a number. It's a number that you know, 2. Okay? But imagine if I would reverse that. I guess something like this. 2 to the x equals, say, 13.2. Well, so what is x? Now that becomes a problem. This is how logarithms were invented, really, to solve something like that. That if the power is an unknown, the base is a known, 2 or 3 or whatever. You know, you can get it even. Imagine if you have something like 13.7 to the power of x equal to, let's say, 320.5, for example. How would you solve something like that? You can't do it in your head. Okay. The way you want to do that is that you have to use logarithms. Okay. So let me give you something really simple. I mean, you will see stuff like that, not exactly like this, but you'll see basic problems cropping up where the logarithm have to be used to solve for that power of x. You know what I mean? Here's one. Suppose I have e to the x equals 13.6. Okay. And you remember, e is just a constant, and I am solving for x. So what is the value of x? So one way to do it when you are faced with those kind of problems, or this one, what you want to do is that you want to project natural log on both sides. So here is project natural log. So you go natural log e to the x equals natural log 13.6. That's the first thing you do. And then you want to use the characteristics of natural log, specifically here, the third one here. Look at that. Here it said natural log of u to the power of n. That power becomes the coefficient of natural log. And keep in mind, natural log of e right there is equal to 1. So let's utilize this. Look what will happen here. This x, let me just use a different color. This x right there, it goes there, so it becomes x times natural log of e equals natural log of 13.6. This one is not a big deal. I can just look up my calculator. I can use my calculator and get that number. But what is ln e? Well, that's equal to 1 times x equals natural log of 13.6. I can use now my calculator. So I go natural log. Go ahead and use it with me, please. Make sure you get the same answer. I am getting 2.61. So I have here 2.61. So x equals 2.61. There we go. Problem solved. You see that? See how useful it is? Okay. Let's do one more. I'm almost done, so just bear with me. Here is one that when you're going to be studying later on in the course, nuclear physics, and we cover something called radioactivity, and you will see the following formula cropping up a lot, which n equals n naught e to the minus, I'm just making up a number, okay, 0.21 t. Okay, so let's suppose I have something like this, okay, and this equation, and let's suppose that this is called exponential decay. Basically, this is a number. The 0.21 is called the decay constant. The t here is the time. N naught is a initial number, and this is a number n after some time t. Okay, so suppose that, if you don't understand what that means, it's okay. Just see it as a math equation. Suppose n naught is equal to 2 times 10 to the 6, and then n is equal to, let's say, 2.5 times 10 to the 4th. And what is the time? What that means is the following. Let me just elaborate a little bit on it. So basically, let's say I have a sample, a radioactive sample, and the number of nuclei in that sample is 2 million right there. N naught means initial time. N naught means initial time. Okay? And 2 million. After some time t, let me use a different color. After some time t, the number became, what is that? 25,000 nuclei. So I'm starting with 2 million nuclei. After some unknown time t, I have now only 25,000. How long has it been? Or how long did it take that sample to reduce in number from 2 million to 25,000? So basically I'm solving for t. Okay? So what you want to do first is you put in all these numbers in the formula. So what I have in here is 2.5 times 10 to the 4th equals to 2 times 10 to the 6th times e to the minus 0.21 t. Okay? And what I want to do is I want to solve for t. Okay? As you can see, the unknown here is an exponent. It's a power. Okay? So I have to use logarithms. You got that? So one way to do it is, first I take this number and move it to the other side. Basically what I want to do, I want to isolate the exponent. I just want to leave it by itself. So I want to move this number over here. So it becomes something like 2.5 times 10 to the 4th divided by 2 times 10 to the 6th equal e to the minus 0.21 t, like that. And I will get that ratio of this one, 2.5 times 10 to the 4 divided by 2 times 10 to the 6. And when I do that, I'm going to get, I don't have it here. Let me see. Let me calculate it. Sorry. I have 2.54 divided by 2e6. Answer. What I will get out of this is 0.0125 equals e to the minus 0.21 t. Okay? As you can see here, now the problem looks a little bit better. So what I want to do now, I want to project natural log on both sides. You see what I'm saying? So I project natural log on both sides now, 0.0125, sorry, times natural log of e to the minus 0.21 t. This is just the left-hand side is just a number, so I can get a log of that. And the log of that is basically negative 4.38 equals to, now remember, if I have natural log of e to the power of n, that makes it n natural log of e. So this whole thing goes to the coefficient here, and then ln e, of course, is 1. So this whole thing basically becomes negative 0.21 t. Okay? The minuses cancel out like that. So t, I can solve for t, 4.38 divided by 0.21, and I can get an answer for that. So I have here 4.38 divided by 0.21 answer. And the answer is, oops, I made a mistake. Hold on, let me do it again. 4.38 divided by 0.21 answer. There we go. 20.9, let's say. Whatever the unit that we're using, 20.9 seconds, months, year, days. I mean, I'm basically just guessing some numbers. So let's say seconds, for example. And there we go. Okay. Let me just review, make sure I've covered one more example, and I promise I'll be done with it. Just one more, kind of a short example on logarithms. rather than not natural log, just logarithms. Let's say here's an actual problem that I have seen in one of the problem in the course. It basically looks something like that. So we have 40 equals 10 times log, not natural log, log, which is to the base 10. Again, it's in your calculator. 5 divided by r squared. And the question is, what is the value of r? Okay? So you already have, excuse me, you already have the log in there. Okay, so what is that? So what you do, first thing, again, you want to isolate the log. So you move this 10 to the other side. So it becomes 40 over 10 equals log 5 over r squared. And that will be 4 equals log 5 over r squared. And then what? What do we do with that? Well, there is a little trick to it. Let me go back to the natural log very quickly. Remember we said natural log of e is equal to 1? Well, it turned out that's also e to the natural log of x is equal to x. That's kind of an interesting equation. E to the power of natural log of x. Basically think of it like the natural log and the e cancel out, and then the x comes down, and you get that. Okay, in other words, if I have, let's say, e to the natural log of 5, that's equal to 5. You see what I'm saying? Another one is, since log, log here, is to the base 10, it has a similar identity, which basically this. If I have 10 to the power of log x is also equal to x. Okay? In other words, 10 to the power of log, pick a number, 5, that's also equal to 5. You can try it with the calculator to prove to yourself that this is a true statement. Why do I need that? Well, what you do kind of the opposite. What you do, because you're trying to get rid of this log, so what you do, you put the both sides here, let me just a different color, to the power, to the base 10. So in other words, you go like this. 10 to the 4 equals 10 to the power of log 5 over r squared. You see the trick? So now, using this trick right here, is 10 to the log x is x, so that's 10 to the log that of this argument is equal to that. So basically this becomes 5 over r squared, and this is just 10 to the 4th, which is, big number, 10,000. So that's 10,000. And all you need to do now, it just becomes a simple problem, cross multiply maybe, or whatever. So you can solve for r squared is equal to 5 over 10,000. And then when you solve it, r equal to, when you work it out, you'll end up with 0.022. And there we go. That's the value of r. Again, to check, all you need to do is you go back to the original equation, here, that one right here, and put in that value of r, the one we just got, this one, and see if you get the same answer. You see what I'm saying? So anyway, that's basically the review that I wanted to cover. I believe this is probably something like almost 80% of the math that you need for the course. If you need anything else, you are more than welcome to contact me and let me know, and maybe I can supply something else for you. Okay? That's it. Bye-bye.